This tech talk. Today we're gonna speak about rules engine as used in PNCP. So, what is a rules engine? It's a pluggable software module, and it allows us to separate the business rules from the application code. So, if you get some business rules, you don't need to implement them in the actual code. You can separate that logic in the rules engine. It allows us to define the business rules using a set of production rules, where each rule consists of a condition and an action. The order of the rules is decided purely by the rules engine. So there is a way to specify the order by which rules are executed, and we'll see later on how. It matches the facts, i.e. the data model, which we inject in the rules engine, to execute specific rules using what is known as the RET algorithm. I don't know if anyone heard of it. We'll go into it later on. So, the advantages of a rules engine. As I already said, it separates the business rules from the application code. It uses declarative programming, so you don't have to focus on how you do what you want to do, but more on what you want to do. There is centralization of knowledge, since all the business rules are in one place. It can reach fast execution speeds, and the rules are quite understandable. You don't have those if conditions. Yes. So, when should we use a rule engine? When a logic involves significant decision making, where we notice that we're going to end up with a lot of if, then, switches and stuff like that. Just go for a rules engine. It's much more clean, and it's basically built for that. As I said, and it's also when the problem is too complex to solve using imperative programming. When the logic changes often, it's advisable also to use a rules engine. And when you want a domain expert to review the logic and the business rules, they are more understandable than imperative languages. When not to use. So if you end up with a lot of rules that you want a specific rule being triggered right after the first one, like you have a workflow process, don't go for a rules engine, because the order of the rules it's decided by the actual rules engine, and if you end up like, I need to change a rule. If you end up affecting all the other rules, it's quite cumbersome, so don't go for a rules engine. So, the architecture. So, here you have what is called production memory, which are known as the rules. They are injected within the rules engine, together with the working memory, also known as the facts, what we call data models. Then the pattern matcher will kick in using the RET algorithm, and we come up with an agenda. And by that agenda, we would know which rules to fire. So which rules are triggered based on the facts that we inject.
Not all rules are fired, the ones that are injected.
No. The rules will go through the RET algorithm, and the rule that matches will get triggered. In one run, there will be multiple rules which get fired, but the filtering happens in here. So, a bit of history about the RET algorithm. It was invented by Charles L. Forgy in 1974. At the Carnegie Mellon University, and he documented it in his thesis in 1978-79. A more simplified version was then published in 1982, And it was the first rule handling algorithm which was efficient with dealing with a large number of rules. So the RET algorithm works by building a network of nodes. So first it starts with all the rules which we provide within what we call the knowledge base. Then it builds a network of nodes. And as we go further down the tree, less rules are going to match with defects we inject. So then the rules that match further down will get triggered. This algorithm it sacrifices memory for increased processing speed. Because the first rule engine algorithms, they were the first pattern matching algorithms. They used to just like, okay, let's match this rule. It matches, no, let's go to the next one. So this was a more efficient implementation. And the performance with this algorithm is independent of the number of rules within the system. It matches the one that the whole condition has to match, irrespective of how long or how short it is. So the first rule that matches all the, eventually it will trigger multiple rules. So if there are multiple rules that match the injected fact, they will all fire.
And to avoid having any overlapping functions.
Yes. In fact, this algorithm, it shares nodes. So since it's a network of nodes, it shares nodes, so as not to end up with a huge tree. So there are variants of the RET algorithm with increased performance, but not all were disclosed. So the RET2 algorithm is one of them. This version was never disclosed to the public, and it was invented in 1980, and it's officially implemented in Philips R2 by Production Systems Technologies. Apparently, Charles Forgy was the chief scientist of this company. Then there's also the VSS Tree, which was developed in the early 2000s. It has 300% boost in performance, and it's implemented as part of Blaze Advisor Rule Server, owned by Pico. And then there's the RET-NT, which was developed in 2010, and it's licensed to Sparkling Logic. Apparently, this company, Charles Forgy, he was an investor and a strategic advisor of this company. So, what about rules? So, this is an open source rules engine. It's a declarative rule-based implementation of the original RET algorithm. And rules are defined in a .drl file. You can have multiple files, obviously. And it provides a .NET and Java implementation. So, let's take an example. So, let's say we're gonna go to an example to reject the application for a driving license. So let's say we have a data model applicant with a name, age, and a Boolean flag valid. So when we inject that to the rules engine, so we can have a rule. In a rules file, you need to specify the package, like in Java. So you have rule, the name of the rule. So when you have when and the condition. So this in itself, when you have an applicant, it's a condition. So you need to have an applicant object for this rule to match. Age, as we saw, is a field within the applicant, and we say that when age is less than 18, then trigger this rule. And here we are setting valid to false, where valid is another field within the applicant, and setValid is the setter of that field within that model. And you can assign an object to an instance so that it can be used within the rule. So, but how do we?
How complex can the rules be? Can they be each other, one calling the other?
Not one call. Ideally, they don't. We don't call one call. You don't have rules one calling the other, but you can inject objects in the action. So you can inject a different object, and then
That requires an order.
Yes, but since if you inject an object, a new object within a particular rule, then the rules that match that particular object will obviously get triggered after, because they wouldn't have found that object, so it's implied. But there are certain ways in which you can specify order. We'll see later on. So, but how do we provide the data model and the rules to the rules engine? So, the rules keeps all the rules and functions and any the model of any types we define within the rules in a repository called the knowledge base. Then the facts, i.e. the data models, are provided to the knowledge session. The knowledge session is created from the knowledge base. So first you create the knowledge base, you say, listen, I have these rule files, that's the knowledge base. Then from the knowledge base you create a session. In the session you inject the data model. So then you execute the session and you say, okay, execute the session with these rules, with these facts. It is important to know that the creation of the knowledge base can be quite heavy. So ideally, you create that as a singleton bean, and then you reuse that for each session you create at runtime. A knowledge session can be either stateful or stateless. By stateful, I mean that the rules can be fired only once on the same fact. So you have to create a new session. By a stateless session, you can iteratively apply rules on the same fact. In fact, you need to dispose the session manually. In the first with a stateful session, it gets disposed automatically right after the first execution. So, I don't know if you can see it. So, here we are creating the knowledge base. And here we are iterating through the files within the class, but these are DRL files containing the rules. We are adding it to the knowledge base. We are building the knowledge base and parsing the files. If there is any problem with the files, it fails here. In fact, here we are checking for the results. If there is an error, it fails. And here is where the actual knowledge base is created. So, the creation of a stateless knowledge session happens just by a single method call. This is, by the way, using Rule 6. I know that Rule 7 came out, but I haven't read quite about the new API.
API base is the knowledge base.
Yes, because they in the Rule 6 they changed the classes, so even in PNCP we had to do some refactoring. And this is how you actually execute the. So from the knowledge base here, we created the session, as Xavier said. We are injecting here. This is a collection of objects that we want to that we want to inject in the rules engine, and then we call execute. This will fire all the rules, which are stored in the knowledge base, and based on the facts you injected in here. And after the rules are fired, it will dispose the session. So that's it.
this will call the file or root, and then the session is closed, right?
Exactly.
So it's like a helper.
Exactly. With a stateful session, you have to do all this stuff. So you create a session. We are inserting the data model objects in here. We are firing all the rules, and then we dispose the session. This can be called multiple times. So the rules in PNCP, it's being used within OCD, which is an integral part of PNCP yacht, and this component is being used to infer the capabilities of a user on a particular organization. It gets the assigned pricing profile of the target organization, the DC capabilities, the risk mitigation of the organization wants to perform the action on, and the authorities assigned to the user, to the logged in user and the organization. And based upon that, we infer the capabilities of the user on that organization.
No rules.
Sorry? The authorities on the logged in user, right? So let's take a look at the flow. So let's say a user wants to perform an action on the UI. The request goes into a client or a resource server, and the method that the client that eventually goes to the server would have a permission evaluator annotation, the pre-authorized annotation. That goes to auth, to the permission evaluator, and the permission evaluator will request OCD to check if that user has access to the particular resource. OCD will evaluate all the capabilities of that user on this particular organization. It returns that result to the permission evaluator, and permission evaluator will return a true or false, indicating whether that action can be performed. And eventually the user will get a response, a page or an unauthorized error.
So this is being done because it's not just if you have permission, but something which is done in the database, but it's to know if you have permission or not. You require a lot of different information from the database, and that's why we're using all the information in the OCD.
We're going into the database and to RBAC services, which is a separate component. So in fact, here we are saying that the rules engine within OCD, first we are hitting the database to get the assigned pricing, the DC capabilities and risk mitigation state. As well, we go to the RBAC services to get the organization and user authorities, what we call the roles and the organization authority groups. Those are fed to the rules engine, and the rules engine will infer the capabilities of the user on that particular organization.
Those would be the facts, right?
Yes, those would be the facts, and then we come up with the where the rules engine validated. They are validated by that method call I showed. So when you create the knowledge base, this call build all would parse and validate the file. Actually, for compilation errors. How would you know it is working? Then you have to create tests. So the actual logic, then you need to test.
No, but I think you can do tests, you inject facts.
Yes.
Run the actual. The same thing as the implementation.
Yes.
You run the execution. And
but you need to write Java test.
And then you know what you expect because you know what you're feeding.
Exactly.
So even the build all is not giving errors, you can have a one-time errors, no?
Yes.
Or behavior.
It depends on the data.
Unexpected behavior.
Like you don't check for a null or I don't know.
This build all would check for compilation.
However, there's a thing which we're not using in OCD, but in Druid 6 there is a new package type format where you can define 6, where you can define all your rules. Basically, instead of being in a jar project, they would be in a new type of project which is specific to rules. And in there you could configure a Maven plugin for rules, which would validate your rules during build time. So you don't have to create a manual Java test to validate.
Usually, the Java that starts for actual test, like import and out, not just
Yeah.
compilation.
But I mean, like, unless you have a test which creates the knowledge base, creates the session, or at least creates the knowledge, you wouldn't know there's a syntax error in a rule. With this, you would know without actually creating any test.
In OCD, there is a Druid sect class. Yeah, actually, it's no, the knowledge base. It's defined as a bean. Yeah. Yeah. Where were we? Okay. So let's have a look at how we're using Druid in OCD. So this is just a chunk, only a part of the model that we are using in OCD, just as an example. So let's say we have a user, and here we are storing the risk mitigation state of the organization owning that user. So what we call as the user organization. Then we have a virtual entity, and here we are storing the capabilities on the assets. So here we have a list of assets. The permission is read, write, create, and delete. So this is the CRUD. We have a map of CRUD and the list of assets we can access. So for create, let's say we have load balancer, VM, CPU. For read, we can have a different list. And the organization is extending this virtual entity. Virtual, because it has access to the assets. It's just how the model was organized. So let's say we want to we have a rule that revokes all pages if the risk mitigation state of the user organization is not good standing. This is because if my organization is not good standing, I don't want to have access to PNCP, so I can't even log in. So I remove access to all pages. So any external classes we use, we have to import them, just like in Java. We can define global variables using the global keyword. So you set the type and you give it the instance a name. So the lock connected true means that if this rule got triggered, don't trigger it again whatsoever. Even if it matches again, don't trigger it again. So that's what it is. Exactly. So here we are saying that this rule to be activated, we need to have a model of user type, and the risk mitigation state of the owning organization mustn't be equal to good standing. And we also need to have an organization model object. This we are using to call a helper method within the organization object, which is defined in Java, revoke access to all pages. And this, sorry?
How is it defined in the web?
Because in order to actually update the organization, it needs to exist. If the organization is never provided, what are you gonna?
So the declaration is done to when?
Yeah, exactly. You need to say that, listen, I'm expecting also an organization object, since I'm going to modify the organization object. And this is just logging. We are using the globally defined variable in here.
Globally, you can also pass to the session,
right?
Yes, we'll see. The session has a set global, and as it's written in here, any global variable which you are going to use within the rules, you need to define in the session. Otherwise, it would explode. So there's a method set global, and you inject the actual instance. The one we're using is stateless. So with this rule, we are revoking virtual services when there are no assets, corresponding assets. Virtual assets, I mean, like VM, bare metal is not a virtual asset, because it doesn't have any asset associated with it. So let's say we have a virtual entity, and we have the assets capabilities which we already saw defined in the model. Here we are expecting a service permissions. We'll see what this is later on. And we are saying that the service must be one of these 7 defined. And here we are, so eval is a way of evaluating an expression. So the expression defined within eval needs to return a boolean. So here we are saying when. So here we are calling another function. The service has cloud assets. So here we are saying when the service doesn't have any cloud assets associated with it, because they have been revoked by other rules, trigger this rule. And here we are inserting a new object to the working memory. So here we are defining a new object, inserting it to the working memory, and this would in turn trigger other rules expecting this object. Okay?
But they cannot be inserted by the algorithm, right? So that would need to be evaluated all the time.
I don't know. I think so. But it has to be evaluated at runtime. Because assets are revoked by the actual rule. So this has to be evaluated after the assets have been revoked.
And what does the insert project is?
This will insert a new object in the working memory.
A new fact.
Exactly.
Exactly. Run rules multiple times.
It wouldn't have been triggered.
It wouldn't have been triggered.
That was the fact in the first. That's what we're saying.
So if it's triggered before, you don't need to trigger it again.
Exactly. So if there was a rule with expecting this object and this object was never present, that means it was never triggered.
Because it's an assumption which might not go away. Correct, right? So if you inject another object or another effect of that type, so you have 2, so then it would trigger one of them, trigger one of the rules, and the other one wouldn't, right?
But that flow connective means do not trigger that same rule on that same object.
Oh, on the same instance.
Exactly.
Or
So here we are circling the stuff which is defined in rules. So these are 5 models, and this is a function. And this is how we declare objects. So import as usual, and you declare object by using the declare keyword. Here you define any fields within the object and their type. And you can have inheritance just like Java. So here we are extending this one. So this would eventually have the service and the virtual entity.
it's not like a Java option.
Then the rules at runtime would generate the bytecode for these objects. So then the rules would generate equivalent Java classes.
Why would you favor the rules declaration instead of Java?
Because they are not actually used by our logic. It's just they are just used within the rules to perform its stuff.
So someone can change the rules, it basically can define the Java.
Exactly.
That's why it's like the values of the actual Java. So everything lives in the rules.
Yeah.
So they're not part of the output of the...
No. They are just used just for the logic. So the equivalent Java class would have the fields, obviously, an empty constructor, and a constructor with all the fields. So that's why I could just create an object passing all the parameters in here, because it creates a constructor with all the fields as parameters. And the getters and setters, the equals and the hash code and the toString. And this is for the child class. Since as we saw in this slide, this extends this. So we have an equivalent Java class which extends this with the virtual entity, and the constructor would have both fields.
That you define the class, or
It's automatically, but I created this for the purpose of the presentation. But it's automatically defined as how.
the way to see this type of folder.
No.
It's actually by
Exactly. So, and this is how we define a function in Druid. So you use the function keyword, the return type, and the parameters just like Java. Here I'm using Java code, so it's a normal for loop, and Druid also supports setting imports. Setting imports are performed by using import function. So here I am importing a static method, and I'm just using it within the root. So instead of importing the entire class, just importing the method and using it directly. Any questions till now? Okay, so let's move on to what we call agenda groups. So rules can be grouped into these agenda groups, and they are supported by stateful sessions, since we can trigger multiple, since we can fire rules multiple times. It makes sense that they are supported by stateful sessions, because a stateless session you fire all the rules, just one run, and then the session gets disposed. And we use this in PNCP to filter out. So there are certain pages where we have the read-only counterpart of the page. So we have like a location limits page, which is the edit page, and then we have the read-only version of the allocation limits page. And we wanted just, and if you have access to the edit page, you don't want to have access to the read-only page. So we are using this. So that's the last thing we do, is filtering out what isn't needed. In fact, here first we are firing all the rules with the default agenda group, i.e. with no agenda group, and then we are getting the agenda group for the read-only pages. We are setting focus on those rules, and we are firing those rules.
So if a rule is part of a particular agenda, it's not part of the default.
Exactly.
can be involved.
No, I don't think so.
It can be, but it won't trigger.
No, as far as I know, only you can define only one agenda group per rule.
You only define one agenda?
Agenda group per rule. So a rule can only belong to one agenda group.
This is the ordering that you have.
Exactly. This is one way of.
And I'm assuming that there is some default group.
Yes. Yes. The default, by not specifying any agenda group. Yeah. So the agenda group is defined right after the rule. There's the agenda group keyword, and you just specify the name of the agenda group. In fact, here we are saying that if the organization is in good standing mode or user suspended, and the organization is not a provider, we are revoking to the read-only page if you already have access to the edit version of the page. So, because you don't want access to both pages, either one or the other.
Revoke access to page.
And just remove.
Here, that's the organization object. There is a message.
Yes, it's a helper message. We just remove the page from ls. Yes, the implementation is within the Java class.
And if an error occurs, that's
It fails. Just stop.
rule or the whole life.
The whole process. That's why we have to. Yes. Yeah. Yeah.
In the end, to avoid this rule, we would have done the read-only page not provided.
Yeah. Another way, I don't know if I included that, but another way to set priority, there's a salient keyword. So right after the rule, you can specify the priority. The keyword is salient. By default, it's 0. And the lower the number, the higher the priority. We are using these.
We are using
Yes.
maintaining them can be
Yeah.
I think we have to reach out the same thing.
Random executed. I mean,
They get executed.
considering everything is at 0.
Yeah.
And the thing is, the group is part of the implementation of the state, so obviously that's to apply to the rules in the same group.
Exactly. Yes. For instance, we have some rules. So if your parent is not good standing, I am changing your state to not good standing as well. So that is the first rule. And then based on that, we are then applying the revocation of pages, and that is so that those would have a higher salience because we need them to be executed exactly.
In some cases, you can avoid salience, so by always adding the condition of the other rule in the current one.
Exactly, but
Of course, you end up with conditions which are new.
and the first rule would be modifying the state of the organization.
So you still need the execution in order.
Exactly.
Ideally, you don't create all of them. Ideally.
Yeah. Or another way could have been by using the agenda groups as well.
You have more control.
Sorry?
You have more control.
Yeah. So, that's all. Any questions?
Is there a way how to get like, imagine if you have a lot of rules, is there like some sort of representation saying which helps you identify like this, there's a group and then there's this stadium, or you just
I never use. I don't know if there are any plugins.
so right now to find whatever, we just go in and see.
Yeah.
For ID, I mean,
Some sort of identity
People
representation.
Gimbals tools have a plugin for SDS Eclipse.
Oh, like which shows you the rules and stadiums and whatever.
Yes, yes. This is a graphic.
Exactly.
So I was wondering, since probably Drupal is using reflection, to, for example, trigger a method, are there convention or something you must do or not to do to write Java facts? For example, specify always interface.
Actually, it's not using reflection. It goes to the setters of the field. So when you have a condition, I know you saw the actual field name. It goes and fetches the setter. So you need to have a public setter for that.
For example, set active.
Exactly.
You can have arguments on that method, no?
Yes, the actual field. So if you have set active, it would expect the access.
For example, using always interfaces, the right interfaces, or I don't know, not extending more than one class. It can be some errors for some time.
I'm not understanding.
No. For example, writing Java 5. Yes. Conventional, for example, never use implementation, but use always interfaces for the Java objects, the facts, I mean.
But if you're using...
For this,
They are Kojo.
Even the super admin is just calling a method for terms of to you give it an object, doesn't really know what's happening, you're just triggering call this method.
In fact, we are even giving it an abstract object. The virtual entity is an abstract object, and we have conditions on the virtual entity. So we are not interfaces, but
You need to have some type of implementation.
Yeah.
So that's for
Yeah.
you.
Because that would definitely maybe in this is
How are these orders? We will copy condition offline. You have like a folder for agenda, or folder.
there is a file. So there is a file per resource. So this file, for instance, the org RM operations deals with rules that checks your risk mitigation state and to which state you can go. So if you are good standing, you can go to on hold. You can go to all the states practically. If you are user suspended, so
they're organized per resource.
Exactly.
And you mentioned, if I understood correctly, the rules engine is built as a tree.
Exactly.
Correct?
Yes.
But then how are they linked together? How are all the nodes linked together?
Based on the pattern, on the conditions.
So the tree is dynamic according to
The conditions.
according to the facts. According to the conditions.
Exactly.
Alright.
And then the fact would traverse the tree based on what is matching.
Some of them are dynamic.
That's what I understand. That's why I
Some of them are dynamic, and depending on the values of the fact, you go to certain.
We're not in one, right? Because we're not in the knowledge one. Knowledge base is only one.
Yes.
But
And that is the tree.
oh yeah, the tree is one. It's the flow that changes, not the. So per condition you have separate branch.
Yes. In fact, that would be creating a different session. So when you make a request and you request to get the user capabilities on the org, and it's not in the EH cache, that's a separate cache. You would go through the entire process, creating a session, firing the rules, and disposing the session.
There are like multiple, and then we have one, and just not this question, if you like, order items, things or a pool of. So if you get requests, they are executed one after the other, or just like
can create multiple sessions from the knowledge base.
That's how we're doing
And then
it.
we got
One knowledge base and creating a session per request.
request and
We have one root, or we have multiple roots.
You will have multiple routes. In one execution, there will routes. There's how the reta works. There's a single reta node, and that is the root. And then we have it branches off based on the different.
Do you define that, or
One root, that would be the first tool that is executed.
what is you define the?
So when effect comes in, it goes through the root node, and
We define the root node, so we have a first rule.
no, it's just the implementation of the ret algorithm. Just how the algorithm works behind the scenes. We don't define any root node. We can set priority on the rules with salience. Let me find one. So here we are saying that this rule has a actually no, the higher the number, the higher the priority, sorry. The lower the number, the lower the priority. So this gets triggered
there is no priority.
And negative.
doesn't matter. You can use both positives and negative numbers within the entire knowledge base. So this entire bunch of files.
So for ordering, there's this and agenda space.
Agenda groups. The agenda groups we're using for the pages which have the read-only content.
When, part of the when and the then.
The when and the then.
But then you also have an option for then.
Yeah.
So,
Exactly.
So basically, once we have initialized the session, then what we do is just call it execute, and then the rules are
Not execute. We are using a stateful session, so we are. Well, yes, definitely. Exactly. So we are creating the session, inserting the data model, and we are firing the rules, and then dispose.
So it's done every time.
Exactly. Actually, we have firewall rules and the rules for the agenda group. So we fire our rules, then we get the agenda group for the read-only pages, and we fire this, and then we call dispose.
and you wouldn't know which rule will be triggered first.
No.
You don't have
After it got triggered, you would know. There is the logging.
Which rule is going to be triggered first?
In theory, yeah, you should. Yeah.
Sorry? It's best practice to use the rule and then make the rules dependent in theory, so.
We'll try to put that concept together with
Able to debug log level, yes.
We're going to have one triggered first. And that's what I'm thinking. To me, that makes more sense.
ordering of the agenda group is done in Java, and the salience is in the groups. So we've got kind of separation of orders. I guess all in one place.
In theory, the agenda group is more of a perform improvement thing, but you segregate which rules
Yeah.
would be triggered by that execution. But then you can call multiple No.
Any questions from Serbia?
Nope.
Anything which we should avoid, like from the syntax kind of. There's definitely some keywords which there's like a label used sparingly or used only if you have no other way to do it.
Try to make the rules less dependent on each other as possible. But there isn't. I don't use all the keywords available. There are way more.
What about modifying the facts in the sense that's considered normal practice?
That is a bit slow. So, in fact, we are using it only in the rm state thingy. When we want to inserting another object within the working memory is considered to be a bit faster. Yeah. Because then there's what is called the modify keyword. That would modify the object, and then it's like performing a new iteration for the entire thingy. So it would start the process all over again. Yeah. So that's why, as much as possible, try to not to use that. Anything else? Thank you, guys.
Thank you.
You're welcome.
Thank you. Bye.
Bye.
Okay, you can do the same with Spring. And I